In this video, we continue on topic 4, which is in rectilinear kinematics in erratic motions, okay, which is on chapter 12.3. Okay. This is the objective of our chapter, subchapter, which is to determine the positions, velocity, and accelerations, which is the kinematics quantities using graph. And this shows the applications of these materials, which is suppose we have normally find out the informations or the graph of V over S. Okay, then from there, how can we find out the accelerations of the system, for example, when it's reached S equals to 1500 feet. Okay, then we can use this method to solve this problem. Actually, the main parts or the main focus on this part, which is to find the slopes, which is to use the differentiations and also the integrations of the curve of the slopes to find out the quantity that we're interested. Okay, for examples, we have an S and T graph, which is the positions and times graph. Okay, for example, this is the ST curve. Okay, then the differentiations of the curve at any point, for example at T1, T2, T3. Okay, actually we notice that ds over dt actually give us the velocity at instantaneous velocity at certain point. Then for example, if we find out the ds1 over dt at this point, we have v1, then we can plot the second point. And then thirdly, if we find out at this point, which is v2, which is ds over dt at t2, then we can find out the speed at v2. And then further, after we complete find out at any instance, okay, then we can plot the vt graph. Then of course we can this is shown by the formula that we learned previously, which is v equals to ds over dt. Okay, then further from vt graph, for examples, we have vt, we can find out the accelerations by differentiate the curve of the graph, which is for examples at this point 0, which is dv over dt, and then we can find out the points of accelerations at 0. And then for time equals to 1, we derive the differentiate again, then we can find a1. And then further, if we do the similar steps to a2 and then a3, then we can plot the accelerations graph, which is the at graph. And then further, in this graph also we can find out the displacements of the systems, okay, which is shown by the area under the graph. Okay, the area under the graph, which is in this vt graph, actually give us the displacements of the systems. And then further, we also have the accelerations over times graph, okay, for example given by this curve. Okay, then of course to find out from this graph we can find the velocity of the systems, which is by finding the area under the graph. Okay, the area under the graph will give us the velocity of the system. Then from there, if we integrate one by one, which is for examples, if we integrate until t1, then we get v1 here. And then for examples, if we integrate second part, for examples, okay, integrate until t2, okay, then so we can have we can get delta v from t1 until t2. Okay, then ADT for example. Okay, then we can find out this point V2. Okay, then the V2 will give us actually the delta V is the difference in velocity from V1 to V2. Okay, then we can find out the graph of V. Okay, then as mentioned previously, for example, right now our graph is the kinematics quantities versus the positions, not versus time. Okay, then this is a more complex case compared to the graph that we have kinematic quantities over times. Okay, here the x-axis of our graph is positions. Then we can use several formula that we have. First, we can use this formula that we learned previously, which is ADS equals to VdV. Then from these equations, then we can find out, or we can get the velocity from this graph, okay, which is by integrating these equations. And for the first one, it will give us this part, which is half of V1 squared minus V2, which is from V1, sorry, this is V0 to V1. And if we solve it, then we have a half of V1 squared minus V0 squared equals to the integrations of ADS from S1 to S2. And then actually these integrations, as mentioned previously, it gives us the value or the area under the graph, and actually give us the information of the speeds of the system. Then from here we can get, if we know the value of V0, then of course we can find out V1. Then further, if we do it if we continue to use these steps for several times, then we can get V2 until Vn. Then we can plot the graph of speeds over positions. Okay, when which is we use this important equations, which is ADS equals to VdV. Then we integrate these equations to get the velocity. Then further, if we have a Vs curve or Vs graph, which is speeds over positions graph, okay, then we can find out the accelerations. Okay, we know that actually we refer back to the equation that we have, ADS equals to VdV. Okay, then from these equations we manipulate that, it will become VdV over ds. Okay, then actually this part dv over ds actually the slope, okay, which is this slope. Okay, then v is the instantaneous velocity at that point. For example, this is the instantaneous v. Okay, then the instantaneous v multiplied by the slopes dv over ds, then we can get the accelerations of a. Then we can get a over here, okay, which is give by these equations. Okay, then if we do the similar step for several other points, then we can get different accelerations. Okay, then what we can get from the velocity positions graph or curve.